Hi guys, now I am explaining about linear regression using RStudio. That is, in first we use general machine learning for Python and generally RStudio also. So I am using this. My data is house price. Houseprice.tsv is my data. First of all, we are saying the data to DT. Run this and store it in DF. Just run it, and we have to view the data. See, this is my data with 19 columns and 506 observations. See, you can see here TF and DT also same. Okay, now summary. Summary means, let's see what is this summary. See here, for every variable there is minimum, maximum, first quartile, second quartile, third quartile, and median, mean. All values are there. So by using this, you can find how much variable is affecting the. This is price is dependent variable and these are independent variable. We have to calculate the price based on these all values. See here Buster, here only S value, only one value is affecting, that is not affecting, it is useless I think. And here some word values are missing, NMs, so we have to fill that. These are concluding from this. Let's see this. We have to plot some graph like this. First of all run this. You can see this for price, crime rate, rainfall and ANA odd bedrooms. Here we see some like this. These are linear relationship but increasing or decreasing, but these are some outliers. We have to solve that because we want quality data. So we have to solve that. And this is not having any linear relationship, somewhat like this. So it look like a logarithm value. So we use logarithm value to solve that and make a linear relationship with crime rate and price, and we use n odd bedrooms to solve out that is outliers. So now we run these busters, that is yes, here only one variable, so we don't need that variable, so I'm deleting it, not affecting, because I will show it. Because if we run airport, here at least there is two values, so this is affecting somewhat, that like, and we run this summary of n rooms, that is, see this maximum is very large, and these are at the same range. We have to change that, so we use again somewhat quartile. There is an thing quartile, we use that to make 3 times quartile value is, by obtaining the data we can make quartile value and assign that value to this maximum above maximum values. So I'm running this. See here, maximum value 46, here 101. So these are similar, and we run the rainfall also. Here rainfall summary is 60, that is maximum 60, minimum 3. This is not comparable, so we change the lower value, that is this lower value using 0.3. Run this, we can see that 3 can change it to 6, that is we want, and we solve this, and we have some missing values NA, that is n house rooms, that is we can say that n house rooms. see here NA, that is nothing is there here. So we have to assign somewhat values there also. So we assign a mean value for that mean of that column data. See, first of all, without NS, the mean value is this, and these are the positions where no value is there, missing value. So we assign mean value to that, and total mean value is changed somewhat. That is, we make a linear relationship between crime rate and rainfall. I said at first, that is, crime rate and price are not having a linear relationship. So I run this. These are linear relationship. I change it to logarithm value. Before it is like this, now it is having some linear relationship. So, and I am using creating a new variable average distance. Distance 1, distance 2, distance 3, distance 4 and all. There are the distances from the house which has to be sold, that employment opportunities. Distances that have employment opportunities from the house where to be sold. So these are affecting same. So I'm doing an average for these values and creating new variable, and I am removing that 4 values from that data. That is okay. Now I am storing that in df2. You can see df2. There is no distance 1, distance 2, distance 3, only average distance. Okay. Now we have some values like this. See, like this: airport, yes, no, 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 and river, lake, non, like this. These values, all values are integers, but for data processing we have to make these values also in 1 zeros or anything type. So I'm making that using this package. We use here packages, like see these packages here. I already installed dummies. Just install that packages of dummies so that are installed. So click on this. This is running now. Then library dummies is provided. So now we can use this to assign dummy values to that. That is this. Run this. Let's see what happens. See here. Here, airport no, 0. Airport yes, 2 columns are there. And for water bodies lake, these are split up into 4 values and given an integer value. Yes, that's what we want. And we don't need any, here 2 values we don't need, only 1 value we can need. So we can delete this, and we can delete any 1 value from this. That is, we will delete water body none. So we'll delete first column 9. That is this. I run this, and if you see, there is no airport, no value, and I will run this again. Then there is water body, none, will not be. See 17 variables. Now we have correlation matrix. That is, we have to see which value is affecting the most the price value. So we are seeing this. Run this first of all. There is nothing, just core of df2. Let's see which value is affecting. Yes, let's see. You can see that these all values are 1 in correlation. The correlation with price and crime rate with crime rate, these are 1 1. And if you see here, same thing, and here the same thing, because it is same. These values are same because here crime rate and price and crime rate 2 are equal. and you can see that minus is not uh, matters here, because minus means decreasing. Just we have to see the value. We can see that here is high value, I think 0.91 air quality, and your park is 0.39. It is less, I think, so I will delete this parks. Let's see, let's round off this to 2. We can easily comparable. Yes, here let's see this. 16th column we have to delete. Our 16th column is this is parks with the 16th column. This is not affecting much, so I have to delete this. So I am deleting this. So see, here 16 variables df2. I deleted that. There is no parks here. Again we have to see. No. Okay, now we have to create nothing. Is this, it is an plotting. We have to create a linear regression. That is, this is so easy, just a simple one-step process. Just run this code. Linear regression means taking only one value, that is, I'm taking just room number and using this and creating a linear regression of simple model. If you see that I'm just plotting this price and number. See, this is linear relationship. We have found this. We have to make a line, every line, then we can see that. Let's run again. See, we can see that it is the line upside. So this is, you can see that there is a linear regression model line. This line is our linear regression line, and we use for another variable also. Any variable we can use, and we can use for age also. Let's run this. We can see this line linear regression. This is only linear regression. If you want to use for multiple datas, you can use multiple linear regression. That is, by using all data you can estimate price value. That is, we can create multiple model like this using the same formula but somewhat difference. Data df2 multi-model. Run this. I have run this, and we have to install a pack to train the data first, and we have to test it. First install CA tools. I have installed that packages CA tools, so I am just tick mark here to run that library and use set.seed of this. Just run this once, and we have to split the data for training process and testing process. So I am using this split ratio function to make that. So here two, training set and testing set. There are two now. Training set is the training set, that is 0.8 data is used for training, and test set is the test set that is used for testing. You can see here 16 variables and 128 observations, 378 observations. I am creating LMA variable to make linear regression among testing set, that is multiple linear regression. See here, I created that LMA. Here is there list of 12 values like that. Let's train that. Create You have to predict and let's view that data, time data. This is the time data that we have got. See this, total 178 entries. This is the time data. We have to test the data. For testing, use the same predict. Oh shit. Okay. Use this, and we can use this test data also. Let's view this. This is the data. Now let's see this test set and training set also. This is the training set and this is the test set. This is the test game output. So you can see that somewhat correct. Here price is 24 and here is 30 and 29 here and 36 here. I think somewhat relationship is there, somewhat accuracy is there. So here is 15 and here also 15, 23, 15 and 15. So by this method you can create multivariable regression also. That's it. I'm closing.